Ladies and gentlemen, welcome to our International Robotics Museum. Here you see a great number of unique exhibits.
The first one is a life-size figure capable of playing a flute. It had a repertoire of 12 pieces. It was created by Jacques de Vaucanson in France in 1738.
Vaucanson's most famous creation is undoubtedly the duck. This mechanical beast could flap its wings, eat and digest grain.
Wow, it can't be true. How can the duck do it?
Animate Arm was the first industrial robot which worked on a General Motors in 1961. The machine undertook the job of transporting die casting from an assembly line and welding these parts on auto bodies, a dangerous task for workers.
Oh, I wish I could create something like that to help people push the limits of discovery.
Shaky the Robot, or Shaky for short, was the first mobile robot with the ability to perform tasks that required planning and route finding. The robot greatly influenced modern artificial intelligence techniques.
I realized future robots will be able to work safely with humans to help them explore deep space and a hostile environment.
The last exhibit is Robonaut 2, or R2 for short. It's the next generation dexterous robot developed through a space agreement between NASA and General Motors. R2's first assignment will be aboard the space station. Hope, Eugene, one, you'll become a great inventor of the 21st century. Good luck.
What was it? So many outstanding inventors and their amazing inventions. Will the guide's prediction come true one day? Since that I had dreamt about my own robot. Last winter I was lucky to take part in the first National Technological Initiatives Junior competition in Moscow. The task to be completed was really challenging. We were to design a CubeSat. We were really embarrassed when we heard that word, because we didn't really know what that meant. However, the jury soon explained what our task was to us. CubeSat is a form of miniaturized artificial Earth satellites for space research, having a volume of maximum several liters and a mass of a few kilos. Designing CubeSats became possible due to the development of nanotechnologies and became widespread in the 20th century. And our goal was to design it in such a way so that all the living biomass in it would remain alive, and all the data on temperature, light, pressure and others would be displayed on the monitor. We had just one day to complete the task. However, we were pretty confused at the beginning of our work, since we had never faced anything similar. We started with constructing the main part. However, we had to reconstruct it when we realized that there were too many wires. Further on, we started connecting data sensors to Arduino. It seemed to be rather easy, but then we didn't have any ports left to connect them. Thus, we had to enlarge the number of ports, adding multiple sockets. After that, we started the process of programming. This was the second most difficult stage of the process, because the main sensor wouldn't work. We decided to do the programming of temperature sensor later. We had little time left. We began connecting the thermoelectric converter. Its purpose was to cool the inner part and heat the outer part. In the heated part, there was a ventilator, which cooled it. Neither did the ventilator function correctly, because it had to turn on with the increasing temperature, but the sensor was out of order, so we connected the ventilator directly, come what may. The last sensor was the light sensor, which turned on the light when CubeSat got dark. The next part was the most interesting but also the most difficult one, placing the wires into the body. There was so little space that living biomass could hardly be there. Finally, we started correcting the code. Suddenly we stopped because we were told that the first team to place the CubeSat on a special platform and start it got 5 points. However, if we took it off the platform, we would get -3 points. We still have a positive score. One of the main factors of the winning was the completeness of the body. We were the only team to structure the CubeSat. Finally, we set our construction on the platform, but it would not function and we had to take it off, getting just 2 points. our light sensor wouldn't function because it reacted to the light emitting diodes on the plate, so we had to use the final variant, use a tape. As a result, everything started to function, but the final task left was to demonstrate the information on the projector. I read the instruction and realized that one word and the names of each sensor's variables in inverted commas should be written to demonstrate it on the projector. Here we are finally, taking our CubeSat to the pad and connecting it to the port. Everything worked, every sensor except the temperature sensor worked correctly. We waited for other teams in excitement and they started to come, the second, the third and so on. In a short time the final scores were announced. And our team won 46 points, which exceeded the second best team by as much as 12 points. We were the winners in the first Russian national competition in robotics.
Mission completed.